Welcome to The Explainer. Today we're going to tackle a common Python puzzle that honestly trips up a lot of developers, new and experienced: variable scope. We're going to figure out what exactly happens when you have variables with the same name in different parts of your code. All right, let's just dive right in with a little code puzzle that gets to the heart of this whole thing. We've got a variable, x, and we set it to awesome. Then we have a function that seems to change x to fantastic. So the big question is, what's that final print statement at the bottom going to show? Will it be fantastic or awesome? Go on, lock in your answer. Okay, so to figure out that puzzle, we've got to start with the basics. We need to talk about the default place where our variables live, and that's called the global space. So what is a global variable? Well, think of it like a giant public billboard in the middle of town. You create it right out in the open, in the main body of your script. And because it's public like that, everybody can see it. Every single part of your code, including all your functions, can just look up and read what's on that billboard. And here's a perfect example of that in action. You see, x is our global variable, our billboard. The function myfunc can easily just peek outside its own little world, find x out in the global space, and use its value. No problem at all. Makes sense, right? Okay, but here's where the plot thickens. What happens when a function doesn't just read that global variable? What if it tries to create its own variable with the exact same name? And this right here is the absolute key to everything. When you assign a value to a variable inside a function, Python's default behavior is to assume you mean a brand new local variable. This new variable is a completely separate thing that only exists inside that function. It doesn't touch, it doesn't even look at the original global one. And boom, that's the answer to our puzzle. Inside myfunc, a new local x gets created and set to fantastic. But as soon as that function finishes running, poof, that local x is gone. It just vanishes. And the original global x? It was completely untouched the whole time. That's why the final print statement, the one outside the function, still shows awesome. So why does Python do this? Why is this separation the default? Well, it's all about a really important idea in programming called scope, and it's basically a safety feature. The easiest way to think about this is that every function lives in its own little bubble, a private room, and any variable you create inside that bubble, well, it stays inside that bubble. It's local, it's temporary, and it can't be seen from the outside. And this is actually a fantastic feature. It's what stops your functions from accidentally stepping on each other's toes and changing variables they have no business touching. Okay, but what if you want to pop the bubble? What if you have a really good reason and you need a function to reach outside itself and actually change that global variable? Don't worry, Python has a special key for that. And that key is the global keyword. It's just one word, but it totally flips the script. When you use it, you're making a very explicit statement to Python. You're basically saying, hey, listen up. The X I'm about to use, it's not a new one. I'm talking about the public one, the one on the global billboard. It's a really clear two-step deal. Step one, inside your function, before you do anything else with the variable, you declare your intention. You just say global X. Step two, now, when you change the value of x, Python knows exactly what you mean. It knows to go out and change the original global variable, not make a new local one. And check it out. Look at the result now. With that one simple line, global x, we've given our function a backstage pass. It now has permission to modify the global state. So when we run myfunc, it actually changes the global x to fantastic. And this time, the final printout reflects that change. We've successfully popped the bubble. All right, so we've seen the default bubble behavior, and we've seen how to get around it with the global keyword. Let's lock this in with one last pop quiz. Hey, this should look pretty familiar, right? It's basically our first puzzle all over again. So think about everything we've covered. What's the final output going to be? The big question you have to ask yourself is, do you see the global keyword anywhere in that function? And the answer is, Python is awesome. Why? Because there's no global keyword. That means Python just falls back to its default behavior. It creates a new, temporary local x inside myfunc. Once the function's done, that variable is gone and the global one is safe and sound. Hey, if you got that right, seriously, great job. That means you've really got a handle on Python's scope. So when we zoom out, what's the big takeaway here? It's not really just about memorizing a keyword. It's about control. You know? understanding the difference between local and global scope. That's what lets you write code that doesn't have weird, unexpected bugs. It's how you make your programs predictable and way easier to fix when things go wrong. And that is a seriously powerful tool to have in your toolbox.